아야 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 두루루루루 아하 아야 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 Yeah Hey here we go again 눈부신 햇살아래 아이처럼 활짝 웃는 너 Yeah Oh hey 같은 꿈속에 우리 계속 불러댄 먼 기억 너머의 Wonderland We're queens in the red castle Don't need crown 타고났지 애써 함께 만들어온 paradigm 확실히 다른 stereotype 볼수록 빛나는 pose Problems 저 하늘 위로 반짝 We are making the rules Cause we are queens and kings 손을 더 높이 모일수록 아름답게 shining bling bling 비가 내려도 strong and beautiful 모두 다른 색깔로 완성한 rainbow 디라뚜빠빠디라 라디라뚜빠빠디라 다시 한번 시작해볼까 That's our queendom yeah 디라뚜빠빠디라 라디라뚜빠빠디라 너와 손을 맞잡은 순간 That's our queendom We strong nothing missing Wake up 답은 simple Be boss 불어 whistle 더 큰 세상이 너를 주목해 축제를 열어볼까 난 너의 손을 잡아 기다린 지금이야 너답게 펼쳐봐 놀라와 my carnival climax 지금부터야 We are making the rules Cause we are queens and kings 손을 다 높이 모일수록 아름답게 shining bling bling 비가 내려도 strong and beautiful 모두 다른 색깔로 완성한 rainbow 더 크게 외쳐 We do it better 어둠을 헤쳐 빛을 따라가 새로운 color 이름은 together It's now or never We got forever Cause we are queens and kings 손을 더 높이 모일수록 아름답게 shining bling bling 비가 내려도 strong and beautiful 모두 다른 색깔로 완성한 rainbow 디라뚜빠빠디라 디라뚜빠빠디라 다시 한번 시작해볼까 That's our queendom yeah 디라뚜빠빠디라 라디라뚜빠빠디라 너와 손을 맞잡은 순간 That's our queendom yeah
Fly me to the moon and let me dance among the stars. Let me know what spring is like on Jupiter and Mars. In other words, hold my hand. In other words, baby, kiss me.
Fill my heart with song and let me sing forevermore. You are all I long for, all I worship and adore. In other words, please be true. In other words, I love
Do you hear me? I'm talking to you. Across the water, across the deep blue ocean, under the open sky, oh my, and baby, I'm trying.
Boy, I hear you in my dreams. I feel you whisper across the sea. I keep you with me in my heart. You make it easier when life gets hard.
Lucky I'm in love with my best friend. Lucky to have been where we have been. Lucky to be coming home again. Lucky we're in love in every way. Lucky to have stayed where we have stayed. Lucky to be coming home someday. Lucky to have been where we have been. Lucky to be coming home again. Fill my heart with song and let me sing forevermore. Tell me I'm the lucky one you worship and adore. Oh, in other words, I love you.
Hello everyone, so welcome back to your Datacom lecture. I know, almost Raya still lecture. Okay, this is the last second already, second last. After this one, this is the last stream. Thank you for coming. I know it's a nice weather to sleep, but just bear with me. Okay, so today we have one last chapter to cover, which is on IP header. So 1 hour I teach you IP header, and then next Friday, last one, the revision class. So no more after that. Okay, so thank you for those people who are still here. Thank you for making this YouTube channel still alive. Now for today's class, I'll make it very simple for everyone. Though we only got one thing to learn. So if you go back to your slide, it is on this part, check this one, IP header. Okay, now this one is in your question 4 in the final exam. So what we're going to do today, you can hear me, can hear me, let me know. I cannot hear. Now we want to understand this thing. So I'll explain each of every one of these what you see here, the version, all these things here. You need to know what is going on and then how we use all these things. Okay, right, but before we start, I want you to understand a bit of the concept first. Now this one is continued from what we learned during the lecture previously. Okay, now before we finish our last class, we learned about this concept called encapsulation. And then I show you that in order for us to send data from point A to point B, we need to put the data inside the box, and the box put into a bigger box, and then an even bigger box. So you go through many layers, the data will grow bigger and bigger and bigger as you package the data before it is ready to be sent. Okay, so the concept, we still need those because today we want to continue from what we learned last week. I mean, not last week, this week. Okay. So imagine this is the data that we want to send now. Okay, now remember when we send data, we must pack it first before we send. So it will go from like that, top to bottom. So when we have a data, now this data can be anything. Can be a picture, can be a JPEG file, can be anything, right? But okay, now when we want to send, we go to layer 4 from 5 to 4. It means that now I will connect. We add a TCP header to this. So now at layer 4, you see, the data in front got one more thing, it's called the header. Now layer 4 is either TCP or UDP. So in this example, I put TCP for you, but sometimes it can be UDP one. So now from layer 4, we now go to layer 3. Now when we go to layer 3, we have to do the same thing. The header in layer 3 is IP, right? So we add IP here. So now you see, it becomes even bigger already. Then this whole thing here from layer 3, we move it to layer 2. And we connect to the Ethernet header because in layer 2 the header is Ethernet. So now you see from 5432 I become so big already. Okay, now and then finally once we have all these things, normally we'll add one more thing called a trailer behind. Trailer is just like it's just a packaging like that. This is called a trailer. then this whole thing will be ready to be sent out. Okay, like that send. So from the sender send to the receiver. Now when the receiver receive this one, it's very big one. You see here is very big one. So the process for now, this is called the encapsulation. So what we want is that the receiver will take back the original data. We don't want all the header one because header is no use one. What I want is the data inside only. So here it will go from bottom to top. So as it go from layer 1 to layer 2, like that, come here layer 2. Now go from layer 2 to layer 3 that time, go like that. I take away this header. So this one I don't want already. I throw away. So I go up here. Now when I go to layer 3 already, I don't want the IP header already. So I throw away. I left with like that. So from layer 3, I go up to layer 2. Then I don't want this already. I throw this away. Throw away. Of course, the green color one early must throw. Now, so you see in the end, I go back to layer 5. I recover back the data that I sent. So what I send you is what you receive one. All the header that we add along the process is no use. It's no use for the user, but it only used for the network because the network needs all this information so that the router the computer everything can know how to send the data to you. Right, so this is what we learned already. Okay, so before we go into today's class is actually very technical. So we have to go through one by one very slowly. Now I just want you to really understand the concept first. Imagine that now I got one data, very big this data. So if I want to send this data from one point to another point, what we just learned is that we have to package it, right? Layer 5 to layer 4 to 3 to 1, and then we send. So when we package means that we are adding headers in front of the data. So all the data that you have on computer network is look like that one. That is a header before you have the data. Understand or not? So you see it's like that one. Now today what we want to learn in this lecture class is here, the header. Right now. So what is in the header? Let me draw one more time for you. Actually what you learn is the same as what you see now. You have the Ethernet, and then you have the IP, and then you have the TCP, and then you have the data. This is what we learned already. Just that before that I draw the other direction. I draw like that. Ethernet, and then got IP, got TCP, and then got data. So it's the same thing one. Just now it's different because I draw in vertical. Just now I draw in horizontal. Okay, so this one is the header. Now all the things that you see here, these are the header, right? And then this is the data. Now what we want really is just the data. The header again is just there because the networking device need that. Alright, understand or not? Okay, now today what we want to learn. Of course, I cannot ask you to learn everything. If I ask you to learn all, you hate me later. So for Datacom, we already selected what you need. Is IP. For this trimester, the exam will focus on the IP only. Why now only evening? Hello, is it very big rain you cannot come? Okay, I want to faster, I want to finish this one. So starting from this point onwards, the next part of this lecture is we want to learn what is inside the IP header. Okay, very detailed, not just what is that. We need to be very good in what is here. Okay, so you can imagine this thing like we take this data, right? We analyze it, we open the content and we want to see what's in the content. Okay, so how do you think what you think is inside here? How does it look like? Okay, this one you will go to the Try Hack Me ROM. I already have this for you. Okay, guys, I need you to go to the Try Hack Me ROM. Now you have two options. One is you can just listen to me. Okay, again, Korean drama without subtitle. Or if you want to do this with me together, then you go to this room, Try Hack Me. Everything that you need for your question 4 is here. Very good. 5-star service for you. Right, so now I want you to look at this diagram first, guys. In your slide, go to your slide and then go here. This diagram, this is what we call the IP header. Right? Now, the whole reason we have this is because as we build packets to be sent from the sender to the receiver across the network, the routers along the way, or in fact any networking device along the way, need a lot of information. just like right now, for us it's the same. If I want to go to KL for example, or Raya long weekend, I want to go to KL. For me to go there, I will need a lot of information. Where do I stay? The hotel. Okay, how do I go there? What is the transportation that I should use? Or who am I going with? And do I go alone or do I go with my friend, right? So we need to have all this detail figured out if we go for a vacation or a short getaway, for example. Now, for data, it's the same. When you send something from point A to point B, to us it looks very easy. But to the machine, it's very, very hard because they have to think a lot of things, a lot of information, like the receiver, is it running a Mac operating system or is it using Windows? Or how fast do you want to send the data? So all these things is very important. And how do we tell the router or the networking device what do we want is by looking at this header. So in fact, right now for the next part, we will understand each of these header, what are they meant for? What is the value that we should put inside when we build packet? Understand or not? And once you understand this thing, then you can do question for 25 mark free for you. Alright, so now I will go back to the Try Hack Me. If you need the link, it's on Weber. You can check on Weber. Again, this is the link. If you open the Try Hack Me, you will see this file. Okay, now first thing you go into the ROM, you will be able to see the download task button. I need you to click this one to download the file. So today, guys, I teach you how to do this, but I use computer. In the final exam, of course, you don't have computer, so you need to do the same, but you use pen and paper. Okay, all right, understand or not? Okay. Now, I will go through the first one, starting with the packet header. Right, guys. First thing, I want to explain how you get this one. Okay, you see, this is our IP header. And is designed by originally is designed by the US so this is how it looks like. Okay, when we do the analysis, the questions is something like that. You download the file already or not, guys? You can download the file. If you cannot download, please let me know. Okay, you need this file. Now the question is like that one. Do you see this yellow color number? So in the exam, you will be given this number. Based on this number, they will ask you a few questions. What is the question? Of course, I cannot tell you here. But what you need to know right now is you need to convert this number into this format. Okay, I will show you how to do it. But before that, first thing is we have to understand what is the header first, right? So looking at this diagram here, okay, start already, ready, it's quite hard one, so I say you must follow. You cannot lose halfway, then you cannot follow already. Okay, so you see, what I have here is a packet template. We can fill up the information as we want. The packet template always got 32 bytes. You see here, 1, 2, 3, 4, 5, 6, 7, 8 until 32. So that means every row, this is one row, is 32 bytes. If I have the second row, is another 32. Sorry, not bytes, sorry, bits. Sorry, guys. So this is all bits. So that means every row is 32 bits. So you see, for example, this 1 means bit 1, bit 2, bit 3, bit 4, bit 5, 6, 7, 8. So every 8 bits is 1 byte, right? So here I got 8 bits or 1 byte. Here I got another 8 bits, which is the second byte. This one is the third byte, and then here is the fourth byte. So again, every row is 32 bits or 4 bytes. Understand or not? So this is the first thing. So you can also look at this diagram here now. So you have 1 byte, 2 byte, 3 byte, and 4 byte. Okay, now that is the first thing. The second thing is, after you understand this template, you will be given this one. Now what you see here, guys, this one spinning on the screen it will be given to you during the exam. So you don't waste your brain power to remember this, okay? It will be given to you. Okay, now what is not given is this thing. So you will have to draw this on your own during the exam. Okay, so you see how I do. Over here, all these field, we call this field, you have versions, IHL, TOS, total length, all these things, they have different size. For example, the version can be 4 bits. This one, the IHL, the second one, can be 4 bits. The TOS can be 8 bits. So every field, the length is different. Understand? So that means you will have to refer to this one during the exam, huh? Can Okay. Now, so the next thing is I will now show you how I copy this diagram to my template. Now, of course, I do this because I want to explain to you. During the exam, you don't have to do this because you can directly do something like this. Okay, I just want to show you how I get here first. So starting with the first one, guys, are you ready? If you are ready, then we will start. Can you see the top left here? We have this version. So this version is 4 bits. 4 bits. So it is starting from 1, 2, 3, 4. Okay, I zoom in a bit so it's easier for us to see. Right. So I'm working starting from here. 1, 2, 3, 4. This is the version. So I got 4 bit is for the version. Right. Now the other 4 bit, look at here, is IHL. IHL stands for the header length or header length. So this one is 4 bits. So again 1, 2, 3, 4. So I got 5, 6, 7, 8, which is the second byte here. Now this 4 bits is for internet header length IHL. Right? Now followed by the next one is called TOS. Can you see TOS here? TOS is 8 bits. So it's different. It's not 4, it's 8. So I got 1, 2, 3, 4, 5, 6, 7, 8. Right now, all these will be used for TOS. So right now here I show you TOS, which is called type of service. I'll explain a little bit more later, right? Okay, so the next one is starting from here. Do you see total length? Now total length is very big. Okay, in fact it's 16 bits, 1, 6, right? So you can count 1, 2, 3, 4, 5, 6, 7, 8. 11, 12, 13, 14, 15, 16. Why I count there like that? 17, 18. 16, sorry, I count wrong. So if you count 17 under the little, this is 16 bits or 2 bytes, right? Okay, so that means this whole thing here will be used for total length. Okay, this is how I get on. So far, can you still follow? Please let me know on the YouTube chat if you are still okay or you want to go pasar malam already, rain stop already. Let me know on the chat if you cannot. Alright, so we continue with the next row. Look at the next row. We are done with the first row. The second one is identification. So for identification is 8 bits. So 1, 2, 3, 4, 5, 6, it's 16. Sorry, 16. So I count 1 to 16 now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 now until here. So this whole thing here is for identification. Okay. Now, then we have the next part, which is flags. Can you see the flags? And then followed by this is called the fragment offset. So we got flags and then fragment offset. So this whole thing here is actually the next 16 bits or 2 bytes is for them. But this is very special. I want you to pay attention here. The flags is 3 bits, right? The flags is 3 bits. So the flags in the header is 3 bits. So like for example, it is only use the first 3 bits and then the next one all follow is for the fragmentation. So this one, can you see here? This 3 bits is for the flag. So in fact, the flag got only 1, 2, 3. This 3 is for the flag, okay or not? So I color this one, border it, and then you can see this is the flags, right? So we use 3 for this one. I color here first. Okay, now that means for the rest here is for the fragmentation offset. Okay, actually this topic is actually quite hard, so you try to follow. So now we done the 2 row already. First row we finish, second row we finish. So far, okay? I'm just filling up this information to the header so that once we have this, you can start to answer the question. Okay or not? Right, now we go to the third row. The third row, now we have the next field here is called TTL, which is actually meant time to live, right? Now this one is 8 bits, so I will count 1, 2, 3, 4, 5, 6, 7, 8, and all this is for TTL, or we call this time to live. Now the other part is the next one is called the protocol. Protocol is 8 bits, so 1, 2, 3, 4, 5, 6, 7, 8, and then we have the protocol here, right? Followed by here, now we are in here already, header checksum. For this header checksum is 16 bit, 1, 6, so I will count from here to here, total I get 16 bit, and this one, they will be used for the checksum later. So we done for the 3 row already. Alright, so far so good. Okay, so now we go to the next line in the header. As you can see, it is for the source IP. And this one is actually for the source IP address. The destination IP is actually the destination IP address. Something that you are very familiar with already. We every day say source IP, destination IP. This is it. So now you see at this on this table here, this source IP is very big. In fact, it is 32 bits. 32 bits means that I start to count 1, 2, 3, 4, 5, 6 until the last bit is 32, which means that the whole row here is reserved for source IP. Okay, now the same thing for destination. Again, destination IP is a 32 bits size, so I will need the whole row starting from first bit to 32 bit, and then the next row is all for the destination IP, like that. So we already have until here. Now the last two is called options or data. This option, I cannot tell you the size because the option size can change. Sometimes it's big, sometimes it's small. So for example, I can only show you example is like now here, these are all the options which can be variable in size, or in fact sometimes there can be no options at all, right? So after the options, it is what is followed by the data. So now if you want to send the data, all the data is here. For example, datacom.pdf or .mp4, the recording or something. So this is your data. So can you see actually if you want to send a video or a picture or a text file or anything, this is what we want to send. This is what is important to us. But before we can send, we have to fill up all this information. Like you need to register first, fill up the form, then only you can send. And you have to do this for every packets. Imagine how many work your router have to do. A lot, very busy one your router. So this part here, do you understand? Please let me know on the chat. If you okay, then only I go on to the next one and I'll show you what is the value that we will put inside. Please let me know on the YouTube chat. If you can hear me, please let me know. Okay, at least one people say okay, very happy. Right, so now the next one, if you look at the Excel file that I give to you, at the bottom here there is IPv4 header. Okay, now what I just explained earlier is the same as what you see here. So this one is for you, free gift, freebie of the day is this one. Now during the exam you will need to use this. Now again, like I said, in the exam this is provided. You don't have to remember any of these things. What is important in fact could be you need to know how big is each of these field. Okay, so this is given to you. Now we will go to the next example. I only have one example, and this one is 99% similar to your final exam. 99%, wow, I got so similar one. Right, so you download the file, and then this is the challenge of today. So like I said, in the exam, they will do something like this. They will give you this one. Okay? And based on this one, you have to answer a few questions. Now, today I also prepared a few questions so that you can do some testing. Then you know that, oh, okay, the final exam is something that look like that. Alright? Okay, so before I start, there's one question. So the second biggest one is option and the biggest is data. Right, so this is a good question. So your friend asking just now based on the IP header that we just see, got some big, got some small. Is the option biggest one? Now, actually I cannot say yes because option is variable size or variable size. Mean that sometimes it can be 2 byte, sometimes it can be 8 byte, sometimes it can be 20 byte. So it depends, no? Sometimes big, sometimes small, depend on the data. Now that's why I cannot say it's very big. Now the biggest one will of course be your data. Your data is normally very big. Sometimes it could be like 500 bytes or 1500 bytes. No? This one, the data is normally very big. Okay. Other than that, I don't think the next one, the biggest one will be the IP address, no? The both source IP and the destination IP. Okay. Now for the try hack me link, I will put it on the YouTube chat, so in case you come late, you can still have. Wait, let me put it on YouTube chat. Today I'm very tired. Okay, so yeah, here you go. For those who want the link, please check on the YouTube chat. Right, now we'll continue with the next part here, okay? So you see, the question will be something like that. What is the source IP? What is the destination IP? What is this and that? Now, before you can answer any of these questions, you need to do one very important step, which is you have to fill up this value to the header, right? So for example, let's say this is the header that we have, okay? I copy and I make a copy so that you can see how I fill up later. Right, so assume that this is the data that we are given in the question, this one. So I have this data here. Okay, I make it bigger. Alright. Okay, now the next thing we need to do is we have to put this data inside, put this inside the header field. And we have to do this very carefully because if you miss one of these, then all the thing will run. Now before you start, I need to make sure you are clear about this. Each hex value is 4 bits. Now all the thing you see here, 4500949F00, all these are hex value. Hex value, hexadecimal. Now means that if I have this example A, I got one hex value A. This one is 4 bits. If I got AA is 8 bits or 1 byte. Okay, this one you must be very clear about this concept first. Okay, so that means every hexadecimal character is 4 bits. If you have 2, means 8 bits, then it's 1 byte. Understand or not? Okay. Now after you understand this one, we can now start to fill in the blank. Very simple, fill in the blank. Okay, so starting from the first number. So you see now what we want to fill is for the version. Version is how big? Version is 4 bits. 1, 2, 3, 4. So 4 bits means that I only need one number because each hexadecimal number is 4 bit. Okay, so that means here the first 4 is for version, the number 4, right? Okay, then we move on to the next one. For header length. So header length is how big? 4 bits. Again, it's 4 bits. So now this is what we have. We used up number 4 already. We go to the second hexa character, which is 5. So one hex value is 4 bits. That means this 5, I will put it here. For the header length is 5, like that. So we fill in step by step, slowly but surely, so that you don't jump one or miss one or repeat use one more time for each of these character. That is very important. Otherwise, all your answer will run. Okay, so I done already. Now we go to the next one, which is for TOS, type of service. Here from the header, we know that this is 8 bits. 8 bits means you need 2 of the hexadecimal number. So we are already here. I need 1, so here is 4 bits. 1 more, it becomes 8 bits, right or not? So here is equal to 0, 0. Like that. So I use until here already. Then I go on to the next field. We just continue this way. And the next field is for total length. Now remember, total length is actually rather big. As you can see, wow, this one is like 16 bit, 16 bit. So how many you need? You need, I think you need 1, 2, 3, 4. You need 4. This one is 2 bytes lah. So you need 4 of this. So here you see, we are here already. Okay, we are here. So this is 1, 4 bit, 8 bit. So this is 8 bit already. 12 bit, 16 bit. So 16 bit we need until here. That means the total length is 049F. Okay, very good. So far, still easy. Okay, so we go on to the next one, which is identification. Now here we know that from the header it is 16 bits. So that means we will need, okay, we are here already. Just now we are already at F. So look at my cursor is here. I need 1 byte, 2 byte, or you can think 4, 8, 12, 16, like that, 16. So the identification is 40 here. 40. Now normally when we write 0x to represent that this is a hex value, but if you don't want, you write like that also can. Never mind lah. Okay. So far so good. Okay, we are already here. Now the next part is for the flex and then for the offset. Okay, now this part is a bit tricky, so I need you to pay more attention. Follow me. We are actually already here. We done here. So now I use another color lah, so maybe you can see what we have used and what we haven't used. Right, so we are here. The next one is 4000. So this 4. Remember that this flag here is actually 3 bits. So the flag is like this, 3 bits for the flag. Alright, so 4 is actually a hexadecimal value. Because this one is bit, right? That means we have one extra step to do. We have to convert this number 4, which is a hex value, to binary first, so that we can fill in the blank in binary notation, right now. Okay, so in order to do that, I will use my favorite calculator, hex to decimal. Now, when in the exam, hex to binary, in the exam, you can use your own scientific calculator. Press, you will get it. So 4, you see, 4, if I convert is 0100, right? So now from here, I know 4 in hex value, 0x4 is 0100. Okay, now I want you to zoom in here. Look at this part here. Because the flex is only for the first 3 bits, right? You see here? So now I will take these 3 bits for the flag. The last 0 I don't use, because the last 0 later we will give it to the offset. Understand or not? So we now will take 0, 1, 0, I put here. So you see here, it will be 0. Okay, sorry, is it correct? Yeah, 0, 1, 0. Let me double check whether this is correct. Yeah, okay, this is correct. Okay, so you see 0, 1, 0. Then for the rest of the 0, 0, 0, 0, 0 here it's all here okay. To make it easy, I don't want to write them in binary because got too many 0 here. So I'll just write like 0, 0, 0 like that. So in fact, it is like that. Okay. There's one more binary bit 0 here but it's fine. Okay. Otherwise you'll be confused. So right now, what is important here is you must be able to see this flag value. In the question, it's always give you hex number only. It don't give you binary one. So it's your job to convert this number. It depending on the question that day, this number, you must convert to binary first, then you put the first 3 bits here, and the rest is all 0. So in fact, it is like that. The 4000 here, you see this one, starting from here until here, this one is for this whole thing is 4000. 4000. Okay, just that I want the first 3 bit to be binary, so I have to convert first. Understand or not? This is the hardest part of this lecture. Other than that, it's very easy. Okay, so now we can continue our journey to fill up all the blank, and the next part is the TTL. TTL stands for time to live. Okay, so we are already here. You see, we are already here. Now TTL is 8 bits. 8 bits means I need 1 is 4 already. No? One more is 8. So got 40 equal to 40. Huh? Okay, now we use until 40 already. Now we are here. For the next one is called protocol. Protocol is 8 bits. 8 bits means we need two characters. One is 4 bit muscle. 1, 4 already. Here is another 4, so 8 bits. Okay, so 0, 6. Come here. Understand or not? Okay, right. So the next one is header checksum. So we already use until here. Okay, I change color so that it's easy to see. So all the green one is used already. Red one used already. Okay, so now we are here already. For the next one is header checksum. From the header you see is 16 bits. 16 bits means that we need 4 of this. 4, 8, 12, 16 or 2 bytes lah. So that means the header checksum is equal to, see this one is equal to 0, 0, 0, 0, 0, 0, sorry, like that, 40. So that is for your header checksum. Now so far we already used until here, all used already. And we move on to the next one. This is the source IP. So source IP is very big. It's 32 bits. 32 bits is 4 bytes. So we have to be careful when you take the number. So starting from here, we are here. So you count 32, 4, 8, 12, 16. And then I think we need a few more. So I got, okay, so this one is 1 byte lah. 1 byte, 2 byte, 3 byte, 4 byte. So I got until here. 2 of this is 1 byte. This whole thing is 4 byte. Right, so we have this one. Understand or not? This is 1 byte, 2 byte, 3 byte, 4 byte. So until here, all used already. Okay, so the next part here is the destination. We are here. We count 1 byte, 2 byte, the 3rd byte, the 4th byte. Done already. So this one is for the destination IP, and we use up all. So in fact, after you fill all, if you don't have any further value to fill, you can just leave it. Right? That means over here there is no options, and you also don't see the data or maybe it's encrypted, or maybe it's not there. So it's fine, because our concern here is we are only focusing on the header part. And with that, we have done filling up all the header. Now before I continue to the questions, let me know on the YouTube chat, are you okay or not? If you are given a string of hex number like this, can you do it yourself, fill it in the blank? For all the different field, you get the value, the hex string into this field. Can or cannot? Let me know on the chat. Give me some confidence to continue. Okay, and also at the same time, if you have any question, you can also ask lah. Can or cannot? Can or cannot? Let me know. By the way, the answer is also given here. Now if you want, you can see the answer is here already, under this one called try, because just now I tried. Okay, okay, nice. Oh, I got confident already. This is what I want to hear. This guy so smart, he know what I want to hear. Right, so now with this, we will now put this beside and we start to answer question. So during the exam, if you think that it is easier for you to compare side by side, you can ask the invigilator to give you one more extra sheet of paper, or I mean one smaller booklet, then you write there, so that it's easier to compare, other than you have to flip like that. Yeah, the whole exam hall very noisy. Okay or not? So you just take 2 and then you put side by side, which is what I want to do now. Okay, you see, once we have the value, the hard part is getting the value. After the value is all in the right place, it becomes very easy. You can just answer the question. Okay. Can repeat the 4 turn to binary. This one, okay, let me explain. Maybe you didn't get it. So just now, when we count until here, we want to fill in the value for the flags. And at the moment, we were here. The next number is 4000. That means this whole thing here, right? This whole thing here is supposed to be 4000. Okay, understand or not? But in the header, it's not like that because the header is in front got 1, 2, 3 bits is for the flag. Now all the thing we write here is hexadecimal value. We don't need to put in binary one. Only for the flag because flag is 3 bits. So this part we have to do into binary first. So because the value here is 4, you see the flag we count until here is 4. This number, right? So what we need to do now is we have to convert this hex number 4 into binary. And when you do that, you get 0100. Okay or not? Now, after you get 0100, we can fill it up here. So here we will fill up 0, 1, 0, and then of course here got one more 0 lah, but I don't show the behind already. And that is how I get the flag value 010. Oh, I hope you can understand already. Can you just ignore the last bit of the flag? Actually, that doesn't matter because the last bit will go into the offset. Now, the offset is not part of our syllabus. You will learn more about offset when you go to level 2 lah. Okay, so don't worry about that one now. Okay, is it only the flag convert to binary? Yes, you are correct. For all the thing that you see here, no need binary. Everything in hex value except only the flag, only these 3 bit. Understand? Very good. Now, we go to the question already. Starting from the first question here. Where am I? Okay, so you get. I want to get a taste of like what you will get on that day lah. So that day you don't be see the question and what is this? Then not good lah. Now you like that, still okay. Okay, so what is the source IP of this packet? Now this whole thing is a packet. With this we can do some analysis. Okay, he asked us what is the source IP. This is the answer that I get just now, right or not? Or I can use this one. This one looks a bit cleaner, right? Okay, so from here, I use this one. Okay, I use this one because the label is there. So you see, this is the source IP. Now this is the answer. Now in the exam, you cannot give this answer because these are in hex value, right? So if you want to write the final answer, you need to convert this one into the decimal notation. Again, how you do it, you press the calculator. So in the exam, you need to save a bit of time because press calculator also takes quite some time. Now you see what I do. I will do it 2 character at a time, starting from C2. You see this is C2, right? Okay, so C2 is the hex number. Convert to decimal is 192. So in fact, after this one, okay, I get 192. Then after that, I convert this A8. Okay, this A8. I convert hex number to decimal. I get 168. Oh, it's starting to look familiar. Sounds like the thing that I say every day. 192, 168. Okay, now here I got 100. Oh, if you convert decimal is .0. Then the last one is 71. Okay, so you cannot write the answer directly. Make sure you remember to convert. The hex 71 convert to decimal is 113.113, and that will be your answer. 192.168.0.113. That is the source IP address for this packet. And once you get the value, you can just write it down already, like that, 192.168.0.113. Both be correct. Finally correct. Of course correct. I said one, I just acting. Okay, so then we move on to the next one. What is the destination IP? Now this one is the same way I do it. From the header that we just fill up the value, I know that the destination IP is this. But again, this is in hex number, so I will have to convert this thing into decimal first. Okay, so the same thing, press the calculator. I cheat a little bit because your calculator is a bit harder to press, not so easy. My one is easier. Okay, hex to binary, and then I convert 79, I get 121. I convert 7B, so do it 2 character at a time, because 2 character is 1 byte. And 7B will give me 123. The next 2 is 1D. 1D in hex value convert to decimal is 29. And then the last one is 83. So 83 convert to hex to decimal is 131. And that will be my destination IP. So with that, now I can write 121.123.29.131, and yeah, that's correct. Or like that only. So you see, now it's getting easy and easy already. After you fill up, the rest of the thing that you need to do is just to find the value, find an answer only. Okay, now we go to the next question here. How to use calculator instead of website? This one, I think your probability lecturer will teach you how to convert, or he said I will teach. Your ICOA lecturer is supposed to teach you. But anyway, if you do not know how to press a calculator hex to decimal, please watch YouTube. Indian YouTuber teach already. Very simple only. I didn't show you here because I don't have the calculator. Okay, so we go to the next question. Is this IPv4 or IPv6 data? Right, guys, this one very important. Now, to answer this question, you have to look at this field. Okay, this field. See this version. Now, when you see the version is number 4, this means this is IPv4. So, looking at version, right, the number 4 means IPv4. Understand or not? So that is how I can know that this data is using IPv4. So I put in the answer here, IPv4. Very good. Understand or not? Okay, now we go to the next one here. What is the header size of this packet? Now this one is a bit hard. I want you, this one is easy. This one is easy. Okay, header size. When you find the data is like that. Okay, let me show you first. Remember just now I got draw something that looks like this. Everything that we said got two parts. Okay, you have the data part, which is what is important to the user, and then you have the header part, which is what is important for all the networking device. Now this whole thing here, we call this the total length. The total length is we measure the whole thing. Why Sengek one? I don't know why I draw Sengek one. Okay, now means that the size including the header, including the data, we call this the total length. But if we only see the size of the header, this is called the header length. Understand or not? So in some cases, we are interested to know how big is this. In some cases, we are interested to know how big is the data. In some case, we may be interested to know the size of the whole thing. Understand or not? So here, of course, you have the data size. Understand? So you can see the total length is actually you combine or you add up the data size with the header size together. Then you get the total length. Now for the next question, we are actually looking at this size. So what is the size of the header? This is what we are looking at, right? So if you go back to your packet analysis here, you can see this is 5. Now from this field, you can know what is the header length, okay? If the number shown here is 5, there is one thing you need to do. So 5 means that remember this is a hex value, so header length is 5. You need to take 5 multiplied with 4 because this is called an octet. So in order for you to get a full size, you need to multiply this with.
Recording in progress.
Hello, I am back already. I struck by lightning. Sorry, I struck by lightning because just now I say the lab test is easy, then suddenly thunder strike my house. So I don't want to say already. Now I continue. I know people never mind. I continue because later they can watch the recording. Okay, continue. Where am I? Okay, just now I was saying about the header length. I don't know how much you already get, so let me just briefly repeat this one. Now again, it's very important concept here for you to know these three different metric lah. So the total length is the whole thing. Every time we send data, we got the data part and the header part. The data part, how big is the data is called the data size. How big is the header is called the header size. Okay, never mind, it's still alive. Actually, I want to see whether you are concerned about me or not. But looks like nobody cares. Okay, I'm fine. It's okay, I'm fine. Right, so now this one. Okay, understand this concept already, right? Okay, so now we go back to the questions and we see the next one. What is the header size or what is the header size? Okay, so this one particular, it means this part. And from the packet that we see here, right? This one here, header length is 5. So can you see H length is 5. So when you get this, you need to do a bit of calculation. Now you see header length is 5. We need to take this value 5 multiply with 4. Because it's an octet. It's not because it's an IPv4. Because it's an octet, right? So 5 multiply 4, you will get 20 bytes. So based on this field itself, you can already know the size of this header is 20 bytes. So you just write 20 here. So it means that what we have here, this one is 20 bytes, like that. Can you understand or not? Yeah, I'm in my house. This one doesn't look like my house map. Is this my office to you? Okay, so yeah, come back to here. We have done the header length, right? So the next part, let's go to the next question. Is there any TOS or TOS set for this packet? So this one is quite simple. Okay, of course the question got easy, got hard one. Some is easy, some is hard. Right, this one is a simple one. Free for you, 2 mark is free. So you see here, if you look at the header, the TOS here is actually 00. So when you see a 00, it means nothing. There is nothing here, 00. Okay, so if the TOS is 00, that means there is no special treatment. Okay. Not understand. Not understand, later you repeat lah. Let me just continue so that I have someone to talk to. Okay, so you look at this TOS. TOS is stand for type of service. Okay, so it's very similar to what we call the QoS. QoS means that, do you know that sometimes let's say you have a lot of people using the internet. You can be playing some game, your friend can be watching a video, and then the other guy can be downloading something. So your router, he have to think that who is more important. If I can only do one thing at a time, should I take care of the guy watching the video first? Or should I care about the guy playing the game first? Or should I care about the one who is downloading? Now we call this the quality of service. Okay, in the router, it is possible for you to set it in such a way that some people is more important than other people. Okay, that is what it means by type of service. Now in this case, it's 00, that means there is nothing. No people is more important than anyone. Okay, so for the answer here is no. Right now, okay. Okay, next. The next one, almost done already. You see, I can scroll finish very fast because later 8 o'clock I got food store, so I want to go already. Okay, now what is the total length? Total length, this one very important. You see, the total length you can get it from here. Look at the packet here, the packet header. Where is my header? Okay, here. Right, focus on this. This is the total length, 049F. That means the total length of this packet is 049F. Now again, this is a hex value, right? So there may be times where you see people write like this. Now, the next thing you need to do is we have to convert this hex value to decimal in order to get the actual answer. Okay, so now I type in 049F and I convert. I get 1183. So that means this number is 1183 bytes. Now from here I know already this is the answer. The size of this whole thing, including the data and the header together, the whole thing, the size is 1183. So this is the answer here, 1183, like that. Okay, so basically what it means is, in our situation here, we have something that looks like this. I have data and I have the header. Now the whole thing here is total length, and this is 1183. This part here is the header length. This is 20, right or not? So in fact, you can know what is the size of the data is 1163. You just minus 1183 minus 20, you get 1163. So this is how we have the size here, the data plus the header. Okay, now after that we can go back to this one, and then you see what is the size of the payload is 1163. Understand or not? 1163, because I take the size of the whole thing, which is 1183 minus of this one, so it's 1183 minus 20 equal to 1163, and that will be your data size. Understand or not? This one is really quite simple lah. Okay, so we go to the last few questions. So what are the flags for this packet? Now this is very simple. From our field, you can see that these are the flags value. We have 3. Starting with the first one is 0, 1, and 0. That means our flags value is 0, 1, 0. And that's it, correct? Okay, so now the next part is this packet fragmented? Okay, this is a bit difficult, so I have to explain more. This one, I hope you can understand this part. Now the flag is 3 bits. This is the flag. Got 1, 2, 3. Now the first bit is reserved. The second bit is do not fragment. The third bit is more fragment. Okay, I write the full name here. This one means do not fragment. This one means more fragment. Okay, now sorry, I covering the whole thing, sorry. Okay, this one. So what you see here is the flags that we have in the IPv4 here, right? So we have 1, 2, and 3 here. Okay, now look at the first one. This one is reserved, means that it's always 0. That means any IP packet that you see, doesn't matter who you send to, what you send, what data you send, when you send, it's all 0. It's forever 0. Okay. Now the second value here means do not fragment or fragment. So this one can be either 1 or 0. If this is a 1, it means that the data that you send, you cannot fragment it. You must send it in one. You see, if this one is 1, it means that you cannot chop the data. Okay, you don't fragment the data like that. So this is actually happening at the IP level lah. What I showed you earlier is happening at the TCP level. Right. So for your understanding, this one means that you cannot chop the data, right? So for the other one, this one means you can chop the data. You can chop and then you can fragment further. So we got 1 or 0 only. If you see this is a 1, means that the data is not fragmented. If you see that this is a 0, means that the data may be fragmented into a few smaller pieces already. Understand or not? Okay. So yeah, this is what it means by do not fragment. The last one here is more fragment. So here is also can be either 1 or 0. Okay. So I write here for you. If this is a 1, I use green color. If this is a 1, means that there are more fragments coming. If this is the 0, means that this is the last fragment. Okay, like that. So the first one is always 0. Don't care. It's reserved, so it's always 0. The second one can be 1 or 0. The third bit can be 1 or 0. Depend. Okay or not? So this one you need to understand the whole concept first lah. Now, then only you can do the question. Okay, so for example now, this is the flag. If this is 0, 1, 0, this one means that no fragment, and this is the last fragment, right? So it means that there is no fragmentation here. Now if you go back to our question now, you see guys, is this packet fragmented or not? The answer is no. Very clear, no, big no, because from here we see that there is no fragment, is set to 1. So of course you may have things like, you may get something like this, 0, 0, 0. Now if you get this, means that there is fragmentation. This one means there is fragmentation. Understand or not? Okay, so this is either 0 or 1. Okay, very good. So this is flag value, correct? These are all the flags value, the 3 bits that I'm talking about. Okay, can or not? Cannot also must can, because you want 25 mark. 25 mark can decide whether you get A or cannot get A. Okay, so I go on to the next one. We got a few more to go. So is there any packet that come after this packet? The answer is no. Okay, so this one I must teach you how to see. Okay, ready guys? This one, one important concept coming up. Right, so this is our bit. Again, this is reserve. This is do not fragment. This is more fragment. Now I want you to focus on this part. Okay, now this one can be 1 or can be 0. Now if this is a 1, it means that there are more fragments coming. If this one means that no more fragment. So what it means is, let's say I got a packet, I got few packets like this, no? This, like this. Okay, now I send this data, all this data, let's say I send from here to here. So I got one sender and one receiver. Okay, I want you to imagine that these 3 data, they are all together, they are supposed to be from one packet. Okay, so try to understand the situation first. So they are all belongs to one packet. Okay, but they are chopped to 3 pieces and then they send out one at a time. So when we do this kind of thing, when we send, this one will travel, this one will travel, this one will travel. Okay, understand? So here it come out, you see, if the first data come here, okay, when this thing arrive, we know that there is 2 more coming, because this thing, whole thing is 3. 3 of them are belong to the same packet. They are chopped to 3 fragments, for example, right? So that means if you look at this data here, the flag will be something like 0, 1, 1. The last bit is 1, so that I know that there are more packets coming. This is not the last one. This is not the end. Understand or not? Now, for example, the next one come already. Okay? Of course, they have their own sequence. I'm not showing you the original sequence. Now, if you, let's say this is the last one, for example, then the next one come. We know that I get 1 and 2. There is one more. This guy haven't come yet. I need to have all 3 come already. Only I can say everyone arrived safely. Right or not? So there is one more. That means, if you look at this one here, the flag value will also be like 0. Oh, sorry, it's 0, 0, 1. 0, 1. So when you look at the 1 here, you know, oh, okay, not finished yet, got one more coming soon, right? Now, if the last one already arrived, all here already, okay? So 1, 2, 3, all here. We can actually reassemble that. Okay, like that. Let's say all here already, okay? So we reassemble them. If you look at this data here, you see inside here, it will be 0, 0, 0. Now the last 0 here means there is no more fragment. Everyone arrived already. Understand or not? So again, to summarize, if you see the data is, the flag is 0, 0, 1, means that behind me still got a few packets coming soon. I'm not the last one. There will be still people coming in. If I see 0, 0, 0 means that behind me no more people already. I'm the last one. If I'm here, that means finish. You don't have to wait anymore. There will be no new people coming. Like I only have 150 people watching this video. I know the last one already. I don't have to wait 300 because I don't know where other people go. Okay, like that. Do you get what I mean here? So these are the flex value. So you can later watch back this video and then you do the revision. Understand or not? But based on what I teach you now, yeah, you can answer the question already. Okay, any questions? If you don't have, we go to the next one, which is on TTL. Okay, this one is also quite simple. The question asking, how many routers can the packet travel before it is being discarded? Now, to answer this question, you need to go back to your packet and then you see this value here, the TTL value. In our example, this is 40. Okay, right, so the TTL means time to read. So it is to use to see how many routers the packet can travel. Okay or not? So this is what TTL means. Now, over here we have the value 40. Remember, this is a hex number, so you always need to convert this one to the decimal number first. Right, so I use my calculator, convert 40. Hex number 40 convert to decimal is 64. 64. Okay, so it means that this router has a TTL value of 64. The TTL equal to 64. Now, what does this mean? This one means, you see, I give you an example. What is TTL? If I got a few router, this is router, all router. Internet is just a lot of router connected together, right or not? Okay, so this is me, this is you, and you send me a data like that. Okay, now you must know that for every data that we send, we have this thing called TTL equal to 64. This is, sorry, I didn't show it. Okay, now I show already. So never mind, you didn't miss anything. Just now I was drawing the network. Okay, so this is the network that I have. I want you to understand what is the TTL concept. So TTL here is 64, based on what I calculated earlier. Right? This is 64. Now what this means is that when a packet travels across the router, we will always decrement the value. So this means that every time packet go through one router, the TTL value is decrement by 1, means minus 1, or means minus 1. So that means if this is the starting one, I go to this router. Of course, this one is my own router, so I don't count. When I go to the next router, this value will become 64 minus 1, it becomes 63. 64 minus 1 becomes 63. Then as I go on to the next one, I become 62. Then I go on to the next one, I become 61. So you see the idea here. Every time the data go through the router, it will minus 1, minus 1, minus 1. So starting I have 64. As I go from source to destination, I minus 1, minus 1, minus 1. Understand? That's TTL. So why do we have this value is because, let's say, in some cases you may have a data that you don't know how to go on. So it may go here, and then it go looping forever. It may be looping. So you see, if I have the TTL value is decreasing every time I go. So for example, if this one here is, this is the data, okay, or the data like that, then the value is 10. Now it will go like that, 9, 8, 7, 6, 5, 4, 3, 2, 1, until when this value becomes 0. Until this value becomes 0, then the router will throw this data away. That is why we have the TTL value. So that if in case the packet forever inside, you need to have a way to kick it out. So we use TTL value to do that. Understand or not? This part, can you understand? Yes, you are right. So if the number becomes 0, the packet will be deleted forever. No more inside the network. Okay? That is why we have TTL. Ah, very smart. So we can continue with answer the question. Where is my packet? Okay, so how many routers can it travel? The answer is 64 in this case. Okay, last 3 already, last 3. What is the checksum value? So for the checksum, we just refer to the checksum header here. The value is 0, 0, 0, 0. Okay, so this one is very easy. I don't explain already. I just put 0, 0, 0, 0. I think the answer want you to put 0x in front. Like that. So 0, 0, 0, 0. Now, the last 2 questions, second last. What is the layer 4 protocol? Now this one, actually the rain very big. I don't know whether you can hear me or you hear the rain only. Okay, now the layer 4 protocol, this one. To answer the protocol, you have to look at this part here. The protocol part. This protocol. Okay, you see right now the protocol is 06. 06 is mean TCP. Now the reason I know is I follow this one here. That is a table for protocol in IP header. You see, now this list will be given to you, so you don't have to remember. You don't have to remember. You just have to know how to see. Can you see this part? See this? Now 06. 06 here is TCP. Like that. So now I know already. If 06 is TCP, that means the answer here is TCP. Like that. Oh, correct. Feel proud of myself. Very good. Last one. So now, the last one is the packet. Oh, okay. Now this one, the last question asks you, this data here, right? This data here, is it sent by a sender, a client to a server, or a server to the client? Now this one, the answer is client to the server, right? So we can check the source IP and destination IP, okay, in order to answer this. Now for our case, actually, if you see the destination IP is here. This question is a bit hard, but it won't be in the exam. It's just for you to learn more. Right, so the destination IP is this one. Now this IP address is actually a server. How do I know it's a server? You see, in fact, if I ns lookup 121.123.29.131. Okay, 29.131. Oh, sorry, I cannot look up IP. I confused already. I think this one, the answer is client to server, because this IP address is belong to Utah server. Now, of course, this one will be in the exam because it's not fair. How can I know this is Utah server, right? So in the exam, you won't get this kind of question. But because now I know, so I tell you this one is the Utah server IP address. That means for our last question, just to finish this up, the answer is client to server. It's sent by client to server. Then ta-da, finish. Finally, we do all already. Now, so what is important is all the questions that you see here, except the last one, is not very important. Okay? Yeah, this is the hardest part. I don't know why my line is not very good now. I hope you can still hear me. Okay, so guys, what I want you to do is you later go back and you already hope when you're free, watch this video again. Just now it's a bit lagging. Now no more already. It should be fine now. Okay, so before you go, I just want to say something about this lecture. It's very, very important because it's one full question for your question 4 in the final exam. is like 99% similar already. On the day you will see, well, like I see this question before, because we already learned it here. So I want you to go back and revise all the things. First is, how do you write the hexadecimal string into the field, one field at a time? And you also need to know like what does all the field represents and mean with all the value inside. Understand or not? Now, if you can do that, if you can know what is the field, what is the value mean in the field, that question is very, very easy. Money back guarantee. Okay or not? Okay. Random Indian guy in YouTube cannot help you. I'm the only guy that can help you. How to calculate the TTL? Okay, now very good question. Now in this case, for our example, the TTL is 0x40. Right? This is the hexadecimal value. Okay, 0x40. Now what I do is I go to my calculator, my best friend calculator. Okay, and then I convert this 40. I convert to the decimal, I get 64. You see that after I convert, I get 64. That means the TTL value is 64. This is how I get it. So from the field, you get the number here, but remember, because this is a hexadecimal number, you have to convert this one back to decimal, which will be 64. Okay. Now, any more questions that you want to ask, you please ask now. If you no question, then I think that's all. Thank you for joining me on my last YouTube stream. I feel so happy that I still see 150 of you here. Although you don't have to be here, but you still choose to be here voluntarily. So I feel so happy. Thank you so much. Now, if you don't have any questions, I will end the stream here. And then I see you on the last class, the revision class on Friday next week. Okay? Why then? Okay, let me explain. One more thing before you go. Let me explain. Now, when we write number, if I write 10 like that, okay, this one, people will see that this is number 10 decimal. If I write 0x10, this one is hex number, hex value 10. This one is decimal number 10. So, you want people to know, this 10, is it hex number or is it decimal number? So if you see 0x in front, means this is the hex number. So you see, if I write 2, this is decimal number 2. If I write 0, 2, this is hex number 2. Understand or not? So there will be a difference here. Okay. What if the fact start from 7 and the binary is 0, 1, 0? Okay, very good question. Looks like you guys are interested. Okay, wait. So I think all the questions your friend asks is very good. Because sometimes I may forget to tell you something important. Okay, if this is the one, okay, right. So we have the bit R, the F, and N. So 0, 1, okay. And then I have one more is 0. Then the last one don't care. So if this is the case, then it means that do not fragment. Means that this one, the data is not fragmented. It's very one big piece of the data. There is no fragmentation. Understand or not? I know that private, don't worry. I will make this video public because I like people to like my video. Huyo Wilson, DM me. I give you extra tip. The fragment offset with 13 bits. Store. No, this one here, store 13 bits of value. This one. Actually, store 13 bits. But anyway, the one of the bit is not really used. It's not used. So in fact, when you actually do the calculation, it's just 12 bits. You will learn more about this in level 2. Level 2, the lecturer will teach you. There are 12 bits of fragmentation, but one of the bits after the fact is not used. Okay? Right. Any more questions? Is there any more thing you can do to add the time to lead? Yes, you can. Now, time to lead can be 1 to 8. 256, 64. If you need more TTL, you just have to set a higher value. That is not a problem. Huh? So let's say you know that, okay, now because every time we go from a router to another router, we will minus 1, minus 1, minus 1, minus 1. What if the place I want to go from and go to is very far? Have to go through 100 router. 64 so cannot reach one. Before I reach there, my petrol finish already gone, kicked out by the router. So you can, in that case, set it to be 128 so that you can minus, minus, minus until when you reach, you still have some TTL value left for you. Huh? Understand or not? Okay, now any more question? How about the 1? Will it go for the next, for example, the next number binary start with 1? Yes, it will go to the next. You are right. This value will go to the next, but it is not used, so we don't really care about that value. Okay or not? Is it possible to have 0, 1, 1 flag? Okay, let me try. Okay. We have reserve, and then we have do not fragment, and then we have more fragment. So 0, 1, 1. Okay, this is what you're asking, right? Let me see. Now, okay, this question, this is not possible, cannot happen because when I say do not fragment already, where is my answer? Okay, you see, when I say do not fragment already, I cannot have more fragment. I already know chopping. So if no chopping, then it's only 1. So here confirm is 0. There's only 1 fragment, so that will be the last fragment. There will be no fragment that come after me. So that is not possible. Okay, now if flag I got 0, 1, 0, 1. Flag is 0, 1, 0, 1. Okay, I think this is the same question. And then the offset I will get 0, 1, 0, 0 or 1. Now your offset you will get this. In this question, your offset you will get this one. Yeah, this is also a very good question. The flag value will still go to the next one. So you get this one. Not 0, 0, 0. Where is it? Sorry, I forget to show. Yeah, this one. So right, if you get 0, 1, 0, 1, the 1 from the flag, the 4th bit will in fact be passed down to the offset. So you get something. The 1 will still go to the offset part. Okay or not? Right? Very good. Everyone is interested in the flag. ACL works based on this. Of course, anything, everything, everywhere that you see in this datacom work based on this, because this is internet model. Every device is based on the internet model. So yes, it based on this. Doesn't matter what you do on the internet. You're watching a video, play a game, download something, it all based on what we learned today. Alright? Any more questions? If you don't have, I want to change to my foot sore shoes already. My friend waiting me. Okay, yeah, that's all for my YouTube stream. Thank you guys for joining me. Very happy to see you. If you already plan not to come for the Friday revision class, then perhaps this is the last time I see you. So I want to say bye-bye. Thank you, good luck, and see you in the lab test tomorrow. And then hopefully you can still come for the revision class. Okay or not? One header then is 4 bytes. There is no QR code. Come on, Bali's already out. You still want QR code? No more QR code. Your calculator cannot convert C2 to 192. You are correct. That's why in the exam there is no such question, because it's too big for your calculator. Don't worry. I know what you need. Okay, so I see you guys tomorrow. Good luck in your lab test. Bye bye. Peace out.